Have you ever been in a car that suddenly turns left and you feel like you're being thrown out to the right? I mean, it definitely feels like something has to be pushing you outward, right? Here's the weird thing: there actually is not a force pushing you outward at all. So let's take a look at what actually happens. So if we have a car here that is turning to the right, and we have the person that is in orange right there. As the car turns to the right, we can see the person is starting normal here, and then once the car is turning here, the person starts leaning to the left, even though the car is turning to the right, and then the person ends up being normal. Why does this happen? So I drew some arrows on the vehicle and the person, so you can see on the first one right here, we have acceleration of the car is going backwards, meaning the car is slowing down, while the velocity of the car is pointed forwards, which means the car is moving forwards. The velocity of the person is also moving forwards. Now, as soon as the car starts turning to the right, we have the acceleration starts pointing to the right, which is due to centripetal force. If you need a reminder what that is, please check out my previous videos. The velocity of the person VP continues moving in a straight line. And I'll get to why that is in just a second. But we see the velocity of the car is starting to turn with the car. And then on picture 3, we have the acceleration of the car and velocity going to the right, which means the car is moving and speeding up to the right. And the person's velocity is also going to the right. Now, why does the person's velocity when the car is turning to the right stay moving forward? And the answer to that question is Newton's second law. Let me just erase. There you go. Newton's second law. So, a recap of Newton's second law is that when an object in motion stays in motion unless acted upon by an outside force. So, here we have the car is turning to the right, but the person is continuing to move forward until the person hits the left side of the car, which pushes towards the right on the person. So the car actually pushes the person to turn to the right. However, if the car door was not there, the person would just continue flying forward and out to the left, which is why whenever a car turns to the right, you feel like you are moving to the left. It is all due to Newton's second law. Now, let's do a worked out example where we calculate the force needed to keep a passenger moving in a circle. Meaning how much does the car here have to push on the person to keep the person moving with the car? So for the example, let's give the person a mass of 70 kilograms, which is about 154 pounds. We'll say the car speed is 15 meters per second, which is roughly 33 miles per hour. And then we'll say the turn radius will be, let's say, 30 meters. All right, and I want to know the force needed to keep a passenger moving in a circle. So first thing I'm going to do is I'm going to find the acceleration first. So we know that acceleration of the car. So we know acceleration is just v squared over r, which is 15 squared over 30, which gets you 225 over 30 is equal to 7.5 meters per second squared. And remember, to find a force, we just use Newton's second law, which is F is equal to ma, which we know mass is 70 kilograms, and we know acceleration is 7.5. So plugging that in, we get a force of 525 newtons. So what that force actually means is the car a seat, or hopefully your seatbelt, or the car door right here has to push with a force of 525 newtons to the right onto the person to keep the person in the car and turning with the car. But the reason you feel like you're moving to the left is because from your left, if you are the person, you have 525 newtons of force going through you from left to right. All right. So again, why does it feel like you're being pushed outward? Because your body wants to keep moving straight due to Newton's first law right here. The car moves underneath you. The seat or whatever the car is pushes you to the right. So in your brain, you interpret that as being thrown outwards. So next time you're riding in the car and the car makes a turn, remember you are not being pushed outward. You're actually being pulled inward by the seat. That is centripetal force in action. I'll see you next time.